In this video, we're just going to explore the concept of simple harmonic motion through some basic examples. So first of all, simple harmonic motion, I'm going to oversimplify this, is a smooth, repetitive motion. Okay, now that's not technical, but we'll add a little piece here that can be modeled by a transformed sine or cosine function, which we know graphs as a wave. Okay, and so let's look at some examples of simple harmonic motion. A first one might be if you have a spring that's hanging with a mass on the end, and then you proceed to pull the spring downward so the spring stretches, and now your mass is down here. And when you release the spring will return to its position of rest, but then it will further go above that position as well. So it will come back up to where it was resting initially, but then the spring will even compress to counter the downward force that was applied initially. And so you can kind of see the spring is going to do this sort of thing. It's going to come up, and then because now the spring's compressed and has that energy, it will release and gravity will pull it back down, and you'll get this sort of wave motion over time. Okay, so a mass hanging from a spring, when you apply a force to it, may exhibit simple harmonic motion. Another example that's very common is a pendulum or a swing. So if you have a pendulum that's hanging like this, and you decide to apply a force pulling it to the left, for example, then the angle, there's an angle here that's formed, and that angle, of course, is going to start back here, and then the pendulum is going to come back to its resting position where that angle is 0, and then it's going to further come over to the right and form that same angle to the right. And then, of course, it's going to repeat. So the angle in this case, so theta would be your y-axis, and maybe time would be your horizontal axis, and the graph might start, if you pull it to the left, you might say that's pulled negatively, and then it's going to go to its resting position, which is here, 0, angle of 0, and then it's going to create a positive angle here, and then it's going to smoothly and slowly come back and repeat, okay? And so on and so forth. So that's the angle formed by a pendulum, and up here we had the distance formed. If you looked at it, if you actually drew a graph of the pendulum, you might have the length of the spring is your measurement over time. And so in this case, if it starts down here, when you pull it down, that would also start at a negative length, come up to its resting position, then go above the resting position, and so on. Okay, and repeat like that. Okay, one more simple example might be a floating bobber or buoy in water. If you have consistent waves and you've got a bobber on top of that wave, or maybe it's right in the middle of a wave, so it's something like this, right? Those are your waves. As the waves come through, you can imagine the bobber is going to be going up and then back down. So in that case, if you look at the graph of the position or the height maybe of the bobber over time, it may start at 0, right in the middle of the wave, and then as the wave approaches, it might ride on top and then come back to 0 and go back down below and back up and so forth. And so those are 3 simple examples. You can see how they might graph. Now in some other videos I'll get into more detail about the graphs and the precision of them, but right now I just wanted to give you an illustration of what simple harmonic motion is.